Hello students, today we'll be looking at basic rules for naming organic compounds. Basic rules for naming organic compounds. Rule number 1, locate the longest carbon chain. Locate the longest carbon chain. Now, for example, we are given a hydrocarbon in this form. Carbon, 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 that is 5. So now the rule says locate the longest carbon chain. You just count 1, 2, 3, 4, 5. This is my longest carbon chain. So in other examples, you will be seeing branch structure. They will not tell you locate the longest carbon chain. So how are you to count? We'll be doing that in this word, in this video. The rule number 2 says name the longest carbon chain. Name the longest carbon chain. This is the longest carbon chain is 5. 1, 2, 3, 4, 5. It's 5. Now you look at your alkane. Because why did I even say alkane? Because in between the structure, I'm seeing a single bond in between the carbon atom in the structure. This is the structure. Then look at one carbon and another carbon. How many bonds do I have here? It's just a single bond. So whenever you see a single bond in a compound, all you see is just single bond in between carbon atom. That means that structure is what is a it's an alkane. It's an alkane. You see hydrocarbon, but an alkane, and they are what saturated what hydrocarbon, because we said that saturated hydrocarbon are hydrocarbon that have a single bond in between their carbon atom. They are alkane. Now look at your alkane. You have number 1. One is what? Methane. One is methane, CH4. Then we have 2 ethane. We have 3 propane. We have 4 butane. We have 5 pentane. We have 6 hexane, 7 heptane, and so on and so forth. So please check my previous video on introduction to organic compound, where I describe the classification of hydrocarbon, the aromatic hydrocarbon, the aliphatic hydrocarbon, and all of that before coming to naming of organic compound. Now, this is number 1. 1 is always methane. 2 is always ethane. Memorize first 10 or first 20 depending on your capacity. Then carbon 1, 2, 3, 4, 5. Okay, let me get to 5 here. This is 3. This one is what? Pentane. Now, carbon 1, 2, 3, 4, 5 is pentane. So the rule number 2 says name the longest carbon chain. My longest carbon chain is what? Is pentane. Rule number 3 says, we've done this. The rule number 3 says figure out what the ending should be. What the ending, in bracket, the surface should be. Now, what is this surface here? Surface is the ending part of a hydrocarbon. For example, we have alkane. The surface of alkane is the ANE. We have alkane. Then the surface is the what? Is the ANE. Then we have alkene. We have alkene. The surface is the ENE. Then we also have the what? The alkyne. Now, what is this? Since all I see here, they are single bond like I described or explained initially, then it means it's pentane. Then the surface is going to be what? ANE. That is why I have my pentane. 1, 2, 3, 4, 5. Pentane. Then number 4 says number your carbon atoms. Then you have to number 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. Why do you number your structure in this manner? You number so that you can be able to give the functional group present in the structure the smallest number. Yes, the smallest number. That is why you number in this form, in this manner. For example, okay, we'll get there. So since I don't even have a branch, I don't have substituent, I will explain. But all I have is just a straight chain carbon. Look at it, carbon 1, 2, 3, 4, 5. I don't have carbon here, I don't have carbon here, I don't have carbon here. So I don't even need to I don't need to number because I just have a straight chain hydrocarbon here. Then number 5 says name the side group or substituent. E.g., we have chloro, methyl, bromo, iodo, and so on and so forth. Now, If we have CH3, let's take for example, I remove this hydrogen, I have CH3 here. This CH3 means a, okay, the hydrogen here. For example, I put CH3 here. This CH3 becomes a substituent. It becomes a branch or a substituent. Do you understand now? Or a group. For example, they can still have chlorine here. Let's say they have chlorine here, Cl, or they have bromine here, Br. Maybe they have chlorine here, or maybe they have bromine here. What do you do in this case? This chlorine becomes chloro. Chlorine becomes chloro. Bromine becomes what? Bromo. This CH3 is the methyl. It's an alkyl. It's an alkyl. ALKYL. So under alkyl, you have what? You have the simplest one. The first one is what? Is methyl, followed by what? Ethyl, followed by what? Propyl. Propyl. It continues like that. All these are, they are alkyl. Alkyl, alkyl, alkyl. And the name of this alkyl is methyl. The name of this one is ethyl, propyl. And their general molecular formula for this alkyl is CnH2n plus 1. While for alkane is CnH2n plus 2. Please check my previous video on introduction to organic chemistry. All these things are there. So for bromine, you write bromo. For bromine, so as a substituent, you write it as what? As bromo. When naming it, it becomes bromo. If you see chlorine, chlorine becomes chloro. If you see iodine, they can put iodine as I like this. This iodine become what? Iodo. Iodo, and so on and so forth. So having done that, now we now move on to number 6. Put the side group in alphabetical order. Put the side group in alphabetical order. What this statement means is that if you have a compound in this manner, in this form, you are giving chlorine, you are giving bromine, you are giving methyl, you look at them in alphabetical order. If we are naming this now, we can say 1, 2, 1, 2, 3, 4, 5, 1, 2. B comes before C. So our name is going to go in this order of, you write bromine first, before chlorine, because B comes before C, and C comes before what? M, which is methyl, which is this one. So you have to, after you have written out what I'm going to teach you, you put them in alphabetical order. So these are the little things you need to understand before we move on to the next stage. All right. Example number 1. Okay, now, first thing first is we look at rule number 1 says locate the longest carbon chain. Now, we look at the longest carbon chain. We count 1, 2, 3, 4, 5, 6. We can still count like this 1, 2, 3, 4, 5, 6. Do you understand? We can count 1, 2, 3. We are looking for the chain that has the longest carbon. The chain that has the longest carbon. So when counting, you can count like this. From here, you can count like this. Like this. You can count like this. You can count like this. You can, for example, we still have another carbon here. You can count like this and like this. So you can as well count like this, and like this. You can count from down here, you go like this, you go like this. But don't count like this, like this, like this, and come back to this place. It's forbidden. Don't go like that, please. You count from here, carbon. You count here, you count here, you can count here. Do you understand? But let's say you still have carbon here. Let's say you have carbon here, then you have carbon here, you have carbon here, you have carbon here. You count like this, you count like this, like this, like this. You can count from here to here. You can count from here straight, but don't count 1, 2, 3 before you start counting 4. It's forbidden. You don't count here, here, you count back before you not count from, or you not count from here. No, you can only count like this to this side and to this side. You can just count from here to here and stop. You can count from here to here to down and stop. Then you can just simply take your straight line. Do you understand? So that is how to get your longest carbon chain. That's how to do that. Then having known that now, our own here is to be, I can take it as 1, 2, 3, 4, 5, 6. So even if I count from here 1, 2, 3, 4, 5, 6 is 6. If I count from the straight line 1, 2, 3, 4, 5, 6, it's 6. So whichever way I count, I'm still having the nugget carbon chain to be what? To be 6 carbon. So I will write. And since it says, rule number 2 says, name the nugget carbon chain. 6 carbon. 6 carbon is what? 6 carbon is hexane. 6 carbon is hexane. Methane, ethane, propane, butane, pentane, hexane. 6 carbon is hexane. Then rule number 3 says, figure out what the ending surface will be. Everything I'm seeing here, they are single bond. Since they are single bond, my surface is A, which is ANA. Then we look at rule number 4 says, number your carbon atoms. Number your carbon atoms. I've already done that. 1, 2, 3, 4, 5, 6. I have numbered that already. Rule number 5 says, name the side group. Very good. Name the side group. I have side group. My side group, my first side group is this one I demonstrated here initially, which is the CH3. Look at it here, the CH3. Then this structure CH3 is the same thing as CH, H, and what? And H. This is the same. This is it here. So now rule number 5, sorry. Name the side group substituent. The first one, I even have two. I have two. So the first one is at position 2. I have the first one, 2-methyl. Then at position 4, I'm looking at this 1, 2, 3, 4. At position 4, I still have 4 what? Methyl. So I have 2-methyl at position 2 and at position 4. Now, let me tell you how to get this substituent. Please pay attention to this part. You know, when I was doing my counting, I counted 1, 2, 3, 4, 5, 6. I did not count this one. I did not count this one. The carbon atoms that I did not count, they are appearing as my substituents. Since I didn't count them, they are my substituents. Do you understand? They are my substituents and they are my group. They are my branch, whichever way you choose to call it. But I prefer using the word substituent for them. So this is one. I counted 1, 2, 3, 4, 5, 6. At this position 2, there is another carbon attached. I did not count this carbon. Position 4, I did not count this carbon. I only counted this carbon 1, 2, 3, 4, 5, and 6. So this one I did not count and this one I did not count. I'm not picking them as my branch. I'm picking them as my what? As my substituent. And what is the position of my substituent or the position of my branch? Is this position 2. Position 2, I have this one, which is this one. At position 4, I have this one. Now, let me take it the other way now. Let me take here to be my 1. 1. Here will be my 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. You see, I did not count this. Please pay attention. I counted this 1. I counted this 2. I counted this 3, 4, 5, 6. I did not count this one. I did not count this one. These two that I did not count now, they will become my substituent if I'm to take this part. If I'm to take this part. I hope somebody is understanding what I'm teaching here. This is, I counted 1, 2, 3, 4, 5, 6. I did not count this one. I did not count this one. I counted 1, 2, and I go this way. This one I did not count become my substituent. This one that I did not count also become my substituent. Do you understand? That's how to choose your substituent. Now, let me still teach you one more thing on this. Now, let me number from here. 1, 2, 3, 4, 5, 6. If I take this, the one I took here now is the upper number written in black ink. 1, 2, I took this first methyl, which is 2. 3, 4, I took 4. Then 5 and 6. Coming through this way now, why did I number top? Why did I number the top side and the under? I number so that I can get this, because this branch, they are supposed to take the smallest number. Each of these branch, they are supposed to take the smallest number. So you have to compare the number written on the top side and the number written under. Which one gives the branch the smallest number? That's the one you have to consider. So I have considered the top, position 2. From the top, position 2 gave me one branch, position 4 gave me another branch. Now let's consider this side. 1, 2, 3. Position 3 gives me from the down under. So position 3 give me 3 methyl. Position 5 also gave me what? 5 methyl. So when naming this compound now, I have to say 2, 4 on this side, 2, 4, 2, 4. Then please obey this your command and this your small dash hyphen. So 2, 4, 2, 4. Since the methyl, since they are 2, 1, another 1, I have 2, becomes 2, 4 dimethyl. The parent name is hexane. 1, 2, 3, 4, 5, 6. Dimethyl hexane. That is the name of this compound. But on this other side now, since let me look at this down, 1, 2, 3, and 5. Then I will now have 3, 5 dimethyl hexane as well. Dimethyl hexane. But this one is correct. This one is wrong. This one is correct. This one is wrong. You know why? We have to take the smallest number of the branch. We have to take the smallest number of the branch, or we have to give the branch smallest possible numbers. So looking at the top, the smallest number is 2, 4. Then under this, the number is 3, 5. 3, 5 is higher than 2, 4. So the correct naming is the smallest number, which is 2, 4, not the bigger one. Then example number 2, you people should attempt this one. This is A part, then the B part becomes C. So okay, this is the compound. How do you name this compound? Then we quickly attach our number: 1, 2, 3, 4, then 5. Even if I count from here, I will still have 1, 2, 3. Here will be 4, 5. Now the naming is like this. This is even a straight chain. If I count 1, 2, 3, 4, 5. If I count 1, 2, 3, 4, 5. Even if I count this way and I count straight, it's giving me the same word, the same number of carbon, which is 5. Then if you look at the top, 1, 2, at position 2, I have one methyl here, I have another methyl here. One here, one here. But if I look at this downside, at position 4, I have one here at position 4. 2 and 4, which one is smaller? 2 is smaller than 4. Since 2 is smaller, I have to go with that 2 and disregard this word 4. Then I will have at this position 2, I have how many methyl here? I have 2 methyl. I have 2 methyl attached to this carbon in position 2. In this case, then I will say that I have 2, because 2 means this carbon 2 is carrying 2 methyl group. 2 means this carbon 2 is carrying 2 methyl group. So this is 2 dimethyl. Then 1, 2, 3, 4, 5. 5 is what? Pentane. So this is the name of this compound. 2,2-dimethyl pentane. That is how you name this compound. I hope that is clear. 2,2-dimethyl pentane. Please do well to subscribe to my channel. In our next video, I'll be teaching you how to name organic compound that has functional group.